Welcome to Two Projects. In this video, we are going to explain the project Developing a Prediction Model for Customer Churn from Electronic Banking Services using Data Mining. Before diving into the execution, let me give you an overview of the project. Firstly, what is customer churn? So, customer churn refers to the situation where customers stop using a service or product provided by a company. This is a significant concern for businesses across various industries including electronic banking services. So, when customers churn, it means they have chosen to discontinue their relationship with the bank, which can have several negative implications. Understanding and predicting customer churn is essential for banks and other businesses for several reasons. So, the first reason is acquiring new customers can be more costly and time consuming than retaining existing ones. By identifying customers who are at risk of churning, banks can take proactive measures to retain them. This might involve offering incentives, personalized services, or addressing any issues that may be driving them away. Another reason is that customer churn can be a signal of dissatisfaction with the bank's services. By analyzing churn patterns, banks can pinpoint areas where they need to improve their offerings or customer experience. This feedback loop helps in continuously enhancing service quality to meet customer expectations and preferences. So, it is very important to understand and predict customer churn in electronic banking services. But traditional methods traditional methods of identifying customer churn often involve manual analysis or simple statistical techniques. So, this typically means someone manually going through customer records, looking for patterns or indicators that suggest a customer might be about to leave. This is time consuming, subjective, that is, different analysts may interpret the data differently or focus on different factors when identifying potential churners. So, this subjectivity can lead to inconsistencies and unreliable results. And traditional methods have limited complexity, that is, they may not capture the complex relationships and patterns present in customer data. Due to these limitations, the accuracy of identifying churners may be compromised. So, there comes machine learning. So, machine learning models analyze historical customer data, identify patterns, and make predictions based on these patterns. They can identify subtle churn indicators and improve accuracy. So, machine learning automates churn identification, identifies complex patterns, and improves accuracy. So, we will be using machine learning algorithms in this project to predict the customer churn. Now, we'll see the workflow. So, for this project, we have used bank churn dataset, which tells us about customers' banking activities and whether they ended their relationship with the bank or not. So, the first step is data exploration. We will explore the data to understand its structure and correlations. Then we process the dataset using different pre processing steps. So, we will drop irrelevant columns and we'll plot graphs to identify patterns. After pre processing, we will use label encoder to encode categorical variables. After that, we will select the important features and we will split the dataset into two parts, dependent variables and independent variables. Finally, we will build various machine learning models, including decision tree, gradient boosting, etc. And we will compare their performance to select the best performing model. So, the selected algorithm will help us predict customer churn based on their banking activities. So, this is what happens in this project. So, overall, the main goal of this project is to create a reliable model that predicts when customers might leave electronic banking services. We are using machine learning to analyze data and give the bank helpful suggestions on how to keep customers happy and prevent them from leaving. This way, the bank can take proactive steps to retain customers and improve their services. And now we'll see the software and hardware requirements. Hardware requirements are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software requirements to execute this project are: application required is Anaconda, primary language needed is Python, front-end framework needed is Flask, backend framework required is Jupyter Notebook, database needed is SQL Lite 3, and front-end technologies required are HTML, CSS, JavaScript, and Bootstrap 4. Now we look at the algorithms built. So in the base paper, author has proposed decision tree, but for improved performance, we are proposing boosting, bagging, and voting classifier in this project. So we will be building all these models in this project. We'll compare their performance and select the best performing one for customer churn prediction. So now we'll understand about the algorithms which we have proposed in this project. So these are all ensemble models. Ensemble models are machine learning techniques that combine multiple individual models to improve prediction accuracy and robustness. We'll understand them individually. The first one is boosting. So boosting is a sequential model building technique where each model corrects the errors of the previous one, focusing on misclassifications. Boosting algorithm AdaBoost is used in this project to improve performance and prediction accuracy in electronic banking data. So this method is effective in capturing complex patterns and improving customer churn prediction accuracy. Next proposed model is bagging classifier. So bagging is a method of training multiple models on different subsets of training data, reducing variance and improving generalization. It involves training multiple instances of the same model on different subsets, such as bootstrap samples, and aggregating their predictions. Random forest is a popular example of a bagging classifier where decision trees are trained on random features and data points. Bagging reduces overfitting and enhances model stability, especially in noisy electronic banking data. Now coming to voting classifier. A voting classifier uses multiple base classifiers to predict the most popular class. So in this case, the bagging classifier, random forest, and decision tree classifiers are combined to provide a balanced approach to customer churn behavior. This approach leverages the strengths of bagged decision trees and a single decision tree, ensuring robustness and improved accuracy. So the combination of these classifiers can effectively identify customers at risk of churning from electronic banking services. So we will compare the performance of all these models. So after comparing the performance of all these models, we have observed that the voting classifier has outperformed all other models in all the performance metrics: accuracy, precision, recall, and F1 score. So we have deployed voting classifier into the Flask framework. Now we'll see the execution of the project. So we will be executing the project using Flask web application. Before that, first we need to open the code folder which contains the project source code files. So this is the code folder. So these are the contents I have in the code folder. So this is archive folder in which I have required bank churn dataset. So the dataset is divided into train and test sets. The train set is used for training the models and test set is used for evaluating the model's performance. So I'm opening the train set. So the bank churn dataset is a collection of data on bank customers, including their demographics, financial behavior, and tenure with the bank. So the dataset includes columns such as ID, customer ID, surname, credit score, geography, gender, age, tenure, balance, number of products, has credit card, is active member, estimated salary, and excited. So the dataset is useful for modeling and predicting customer churn in electronic banking services as it indicates whether a customer has churned or not. So the target variable, that is excited, in which I have two class labels 0 and 1, is particularly important as it indicates whether a customer has churned or not, making it suitable for predicting and modeling customer behavior in electronic banking services. So we will be training the models on this dataset. Similarly, in the test data, I have the same columns. So on this dataset, we will evaluate the model's performance. So in this dataset, I'll not have the target variable. So we'll evaluate the models on unseen dataset. That means we'll not have the target variable here. This is about the dataset and this is static folder. So this folder consists of files related to CSS, JavaScript and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes coded in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. And this is a model file which contains algorithm information. This file will be loaded into the project code during runtime to utilize the trained models. This is Notebook Jupyter source file, which contains a combination of code, graphs, and outputs all in one place. So Jupyter Notebook allows users to write and execute code in individual cells, making it a popular choice for data science. This is sample file in which I have test cases on which we'll make the predictions. And this is signup.db file. This file is the database file used to store user information. So now copy the path of the code folder from the address bar of the file explorer. I'm copying it. Open Anaconda prompt. Use the command cd followed by a space and paste the copied path and hit the enter button. So this command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command is used to execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, localhost, and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. And here we can see a sign up link, click on it. So if you are new users, we have to register ourselves first, fill in all these details and click on register button to sign up. And if we already have an account, we can directly log in by clicking on this link. So as I'm already a member, I'm clicking on this link. Here we have to give our credentials, username and password. I'm giving mine and click on login button. So it has redirected us to the predictions page. So now we have to fill in these parameters and click on predict button to get the predictions of customer churn. First, we'll understand these parameters. So credit score of the customer is a numerical representation of their credit worthiness. The next one is gender. So this is the gender of the customer. Here we have to enter the age of the customer. Tenure is the number of years the customer has been with the bank. Balance is the amount of money in the customer's account. Number of products is the number of products or services the customer has with the bank. Has credit card is a binary indicator indicating whether the customer has a credit card with the bank or not. Is active member is a binary indicator again indicating whether the customer is an active member of the bank or not. and estimated salary is the estimated salary of the customer. Now we'll fill in these parameters. So credit score would be 539. We have to choose the gender from the drop down here. I'm giving it as male. Age would be 39. Tenure is 1 year. That is, he has stayed with the bank since 1 year. Balance is 0. That is, he is not maintaining any balance with the bank. Number of products would be 2. That is, he is having 2 products with the bank. Has credit card is yes, he is having a credit card from the bank. So it is 1. Is active member? Yes, he is an active member. So it is 1. Estimated salary is 86,792. Now click on predict button. So here we can see the result, that is the customer won't exit or churn the bank. He will stay with the bank based on data provided. So according to the given set of parameters, the application has predicted that this person will not leave the bank soon. He will stay with the bank. We'll try again giving another set of parameters. Click on prediction link. So this time credit score would be 714. Gender is male. Age would be 43. Tenure would be 6 years. That is, he has stayed with the bank since 6 years. Balance would be 0. Number of products is 1. He's having 1 product from the bank. Has credit card is 0. He doesn't have a credit card from the bank. Is active member is 0. He's not an active member. And estimated salary is 1,41,914. Click on predict button. So here we can see the result, that is the customer will exit or churn the bank. He will not stay with the bank based on data provided. So according to the given set of parameters, the application has predicted that this person will leave the company, leave the bank soon. He will not stay with the bank. Click on prediction link. We'll try again. This time credit score would be 651. Gender would be female. Age is 42. Tenure would be 8 years. Balance is 0. Number of products would be 1. Has credit card is yes. That is 1. Is active member? Yes. And estimated salary would be 1,43,345. Now click on predict button. So here we can see the result, that is the customer will exit or churn the bank. She will not stay with the bank based on data provided. So similarly, we can give any set of parameters and can get the predictions. Click on prediction link, enter the values here. Credit score would be 693. Gender would be female. Age would be 38. Tenure is 1 year. Balance would be 1,37,948. Number of products would be 1. Has credit card is yes, that is 1. Is active member, that is 1. And estimated salary is 84,760. Now click on predict button. So here we can see the customer won't exit or churn the bank. He will stay with the bank based on data provided. So this customer will not leave the bank soon. She will stay with the bank. We'll try again. Click on prediction link. This time credit score would be 627. Gender is male. Age would be 30. Tenure is 1 year. That is, he has stayed with the bank since 1 year. Balance is 0. He is not maintaining any balance in the bank. Number of products is 2. He is having 2 products in the bank. Has credit card is yes. He is having a credit card. Is active member? No, that is 0. And estimated salary would be 1,32,450. Now click on predict button. So here we can see the result, that is the customer won't exit or churn the bank. He will stay with the bank based on data provided. So this person will not leave the bank soon. He will stay with the bank. He'll continue with the bank. So in this way, we have to give the parameters here. Click on predict button and get the classifications if the person will leave the company, leave the bank, or he'll stay with the bank. Now we'll look at the visualizations plotted. Click on the graph link here. Here we can see all the visualizations made. This is sample outcome graph which displays the distribution of labels. So in this graph on x-axis I have labels and on y-axis I have count. So from this graph we can say that there are more number of cases in the data of the persons who are staying with the bank. And these many people are going to leave the bank. This is correlation matrix graph. This is accuracy scores comparison graph, the horizontal bar graph comparing accuracy scores. So in this graph on x-axis, I have accuracy scores and on y-axis, I have algorithm names. So accuracy is a measure of how well a model correctly predicts outcomes. It represents the proportion of correctly classified instances among all instances evaluated. Similarly, this is precision scores comparison graph. In this graph on x-axis, I have precision scores and on y-axis I have algorithm names. Precision is a measure of the correctness of positive predictions made by a classifier. This is recall scores comparison graph. So recall is a measure of the classifier's ability to correctly identify all relevant instances from a data set. And this is F1 scores comparison graph. F1 score combines precision and recall into a single value. It provides a balance between precision and recall, taking into consideration both false positives and false negatives. So by looking at these graphs, we can say that voting classifier has outperformed all other models. Now click on sign out. So we have built a system that predicts when customers might stop using online banking. After testing different models, we observed that voting classifier outperformed others, and we have deployed it in Flask. And we have tested the system by giving parameters and getting the accurate results. So this system helps banks keep customers happy, save money by using resources better, and make smarter decisions based on data.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.